Hi, it's Miss House. In this video, I'm going to go over more derivative shortcuts. So we've been doing the derivative, that is the instantaneous rate of change, by taking the limit as h goes to 0, f of x plus h minus f of x over h. And this is to get us used to the idea that this is the slope, but at one specific point. As we move the point from a secant line like this, and this distance h goes to 0, and we move this point back to here, we've got a tangent line. Okay? And so that's what that formula does for us. That's called the derivative. In a previous video, I talked about the following, that if f of x is c, a constant, then its rate of change, f prime of x, is 0. Why is that? Well, constants don't change. Okay, constants don't change, so when you take their derivative, which is how much they change, you say 0. We also talked about a power rule. So if f of x is some base to some power, okay, and p is between negative infinity and positive infinity, that can be any number, then f prime of x is the power times the base to the power subtract 1. If there happens to be a number in front of that x, so we'll say we've got a constant times x to the p, we're going to do it the same way. We're just going to say the constant times the power times x to the power minus 1. So this power rule, or these power rules, are very important, and they make our lives so much easier because we no longer have to struggle with the algebra of that long definition of a derivative. So let's look at some functions that may not look like they have a power rule, but they do. F of x equals 2 divided by x. Whenever we have 1 over x, that can be rewritten as x to the negative 1. Or if we have a constant over x, that can be written the constant times x to the negative 1. So I'm going to rewrite this as 2x to the negative 1. So my derivative, following those previous rules, is going to be 2 times negative 1 times x to the negative 2, because when you do minus 1, you're at minus 2. And so I can reduce this to negative 2 over x squared. So that would be the derivative of 2 over x, negative 2 over x squared. So this is the formula for the slope of the tangent, right, which is the instantaneous rate of change, and it's at any x. So all we have to do is know what x we are and just plug in our x. Now another one you might see, f of x equals 3 times the square root of x. This is also a power because the square root of x can be written x to the 1/2 power. So this is 3 times x to the 1/2. And when I do my derivative, f prime of x is going to be 3 times 1/2 times x to the 1/2 minus 1. And 1/2 minus 1 is minus 1/2. So this is 3 over 2, right, because we have this 2 in the denominator right here, and this 3 is a numerator. It's a 3 over 1, so it's going to be a 3 over 2 x to the negative 1/2. Well, that means 3 over 2 x to the 1/2, and now we're going to go back to square root. 3 over 2 times the square root of x. And we're not going to worry about having a square root in our denominator because we're just going to be given a value of x like 4, and we're just going to plug it in. So as you encounter future problems where they ask you for f prime of x, instantaneous rate of change, the derivative, these are all words that mean and symbols that mean the same thing, the slope of the tangent, or marginal analysis, so like marginal profit, marginal cost. Okay, those are all things that are the derivative, and we can now use these shortcuts. Now, I will ask you to use the long method once on a polynomial function. So something like f of x equals x squared minus 3x minus 4. So you'll have to do the long formula, the limit formula, at least once on an assessment, but probably not more than once, just to show that you know what the definition is. We're going to use these shortcuts. It's much more efficient, and there are a lot more shortcuts that we have to learn, but these will get you through these initial sections.